Okay, so now we're going to switch back from math mode into code mode. And I think I can hear all the students saying, hallelujah. Okay. Now, what I notice is that students tend to have this math phobia, and I really hope I can break through some of that and show you. Even though it's different, doesn't mean that it's any harder or any less capable of it. So I hope that you can get into some of the math, but I'm not going to beat you over the head with it. But I do need to kind of prove these things and show them and establish them rigorously. I believe that's part of what I need to teach you. But I'm not going to ask you to come up with proofs on your own, usually, unless I've shown you the technique before. So I will ask you to design algorithms, but for the analysis, I feel I need to fill in the gaps. So anyway, I just wanted to say that. So don't let this get you too anxious. But we are going to go back to code now, and it's going to be something that you've seen before in 174. So we're going to talk about linked lists, and we're going to define them in Python. And then I'm going to have you think about the time complexity in big O notation of different operations in the implementation that we do here. Okay. So if you recall, a linked list is really a bunch of bins that are connected to each other by arrows. Okay. And a linked list also has, okay, so these bins contain the values that we're storing in the linked list. But we also need to know where to start. So the linked list has something called a head. So each of these bins we refer to as nodes, and then the head node points us to the very first bin. Okay. So that's a linked list in a nutshell. So the question is, how do we turn this into Python code? So we're going to use object-oriented programming Python to create linked lists. So let me show you what that looks like. So just like we did back in the day in 174 in Java and C++, we're going to have two classes that work together here. So the first class is going to be a node class. So a node is going to store a value and also a pointer to a next node. So I'll say def init, so here's my constructor, self value, and I'll say self dot value equals value. And then I'm also going to initialize a next pointer. So that's these arrows. Now, so Python's version of null is actually none. Okay. So that's a type actually that means nothing. Okay. So as soon as I get to the end of the linked list, I should be pointing to none because there's nothing there. So that's how I know I've reached the end. Okay, so that's all there is to deal with for my node class. Now let me make the linked list class. So in this case, we'll start off with nothing in it. The only local variable that I need for a linked list is the head, so I need to know where to start. But when the linked list starts off, there's nothing there. Okay. All right, so this is not too useful yet, but let's start to define some operations. So let's say I wanted to add something to the linked list. Okay. So what I have to do is make a new node. And, so I'll call the constructor that way. And when I'm adding something to the linked list, what I do is a little bit of surgery here. What used to be the head is going to stay as it is, but I'm going to put something before that. So I'm going to make a new node. So I'll call this new value. And that, actually the head now needs to point to that. And that needs to point to what the head used to point to. So that's the idea. Okay, so let me do that. So let me remember what the head was before. But now I'm going to make the head the new node. And I'm going to make the new nodes next what the head was before. Okay, so that's how I add something to the beginning of the linked list. Now at this point, let me actually make a toString method. It might be nice to print out what's in the linked list. So remember how we do that. We have this special method called underscore underscore string underscore underscore. And this is supposed to return a string representing the list. So what I'll do is I'll just say node equals the head. I'll say while node. So here's an interesting syntax. This will only evaluate to false if node is none in this case. So if you're checking for none, instead of saying node equals none, it's actually not node. Okay, so anyway, this is a nice little thing you can do in Python. So I'll say while node, I'll say s plus equals node dot value, and then I'll put a little arrow, cute little arrow to the next element. Okay, and I'll return s. All right, so hopefully we understand what a linked list is. I'll come back to this when I show other operations, but let me make this a little bigger so we can see all the code together. So here's my linked list. So let me test it out. And I'm just going to put a few values. So I'm going to say l.add, so they're always added at the beginning. So I'll add a 10, then I'll add 4, then I'll add a Chris. Actually, the cool thing about Python, I never specified the type of the value, so it can be any type. So now if I say print l, it goes into an infinite loop. Why is that? Because I have to say node equals node.next. Okay, so I'm walking along. The idea is I start at the head and I walk along and follow these arrows until I get to the end. All right, so even I make infinite loops sometimes. Okay, I do need to do slightly fancier string formatting here than I was doing. Okay, this should do it. So I want to show you my process too. I don't always get code the first time. All right, cool. So we got Chris, 4, 10, and then we're at the end. So that seemed to work. And look, boy, this is nice compared to what we used to do in Java and C++. I really like that. Okay, so let's just add a couple more methods to our API. So I'll add a method remove first. So it's going to remove and return. I should be adding doc strings here. So you know this was the this is whatever I was adding. Add a new node to the beginning with this value. Remove first is what this should be doing is remove and return the first value from the linked list, or return or do nothing and return none if it's already empty. Okay, so I'll say my ret is equal to none, so I'm going to assume that maybe it's empty, but if it's not, so if the head is not null, then what I'll do, okay, now let me go back and draw this. So when I remove something, what I have to do is say move the arrow from head to jump past what the first value is. Okay. Actually, first, maybe I better say, okay, ret should be head.value. So I'm going to return the thing that the head stored, and then I'm going to get rid of the head. So I will say, what that's like saying is head is equal to head.next. So head points to this, head.next is this, so I'm going to jump over what it was before. And because I'm not doing explicit memory management in Python, I don't have to delete the old head. Something called the garbage collector will clean it up for me. So unlike C++, I don't actually have to delete the old head. It'll be taken care of. All right, so let's just check to make sure this works. So I print out the list at this point. Now print l.remove first. That should print Chris. Of course, I have to rerun this code first. And I made another mistake. which is every local variable you have to refer to as self. Okay. Now we should be good. Let's try this. Yep, okay. So I saw that I was able to remove Chris from the beginning. Let's make sure that that actually happened. Okay, cool. So it seems like, I mean, this is, I need to test it more than this, but it seems this is evidence that this is working properly. Okay, there's another, I just want to show you another nifty thing you can do in Python. What if I want to keep track of the length of this list? So maybe I have a variable, which is the length, I'll call it n. Every time I add something, n goes up by 1. And if I manage to remove something, then I say n goes down by 1. So there's a special method in Python in every object or every class called len underscore underscore. And if you return some variable that specifies the length, then you can use this len. So just like we did with the list, we've now defined for Python what it means to say the length of this object. I'm just going to run that again. Okay, so the length is 3 at the beginning, then we remove Chris from the front, now the length is 2. So I always loved this. I thought this was such a nifty thing you could do. So if I have a similar API for another kind of collection that adds things and removes things, then I could just swap in that collection and I can report the length the same way. Okay, now something that's a little trickier is if I want to add something to the end of the linked list. So let's say I came in with another new value and I wanted to add it to the end. So what I would have to do is create a pointer. So I'll just call this node. It's going to start off pointing to whatever head does. But we're going to keep walking. We have to keep walking along and following the next arrows. So we're going to follow the arrow. Oops. So now we're going to go here. Then we're going to follow the arrow here. Then we're going to follow the arrow here. And at this point, what we're going to notice is that the next would be none. So we actually want to make the next be the new node at that point. So that's the picture. So I'll make a method called add last. And just like before, I need to make a new node to hold this value. But this time, I'm going to do something a little different. So I'll say while node.next is not none. So as long as there is, the arrow actually points to something that's not none, then I'll say node equals node.next. But as soon as the next is none, then I know I've reached the end, and I can say node.next equals new node. Okay. So again, I had this thing called node that walked along until I found that the next thing was going to be null. And I knew that that's where I could splice in this new element. Okay. And everything's initialized with a next of none. So we know that this new element that I'm adding in here is also going to point to none. So let me try to mess around with this then. So I'm going to say l.add Layla, my cat, at the end. And actually she's above my dog Theo, so I'll add Theo even after her. So let's see. So sorry, this is add last. So let's see if that worked. Of course, I got to run this code again. Okay, now I've got the method. Good. So I added Layla, then I added Theo. One thing I forgot to do, which you notice, is I didn't update the length. So it still thought the length was 3 because I called the regular add method 3 times, but I also have to remember an add last to increase the length. Okay, so it seems like this is all working. So now that I've done this, I'd like you to think about what is the time complexity of all the methods that I've put here. And tomorrow we're going to see in class if we can improve the time complexity by changing the data structure a little bit. Okay. So we might have the same extra data type where it's some list, some ordered list where you can add things at the beginning or at the end. But we might want to do some things more efficiently. Okay, so that's it.